All right, guys, thanks for joining. I hope everyone can hear me loud and clear. Please drop a message if my voice is not proper, if it's not clear. Okay, let me first introduce myself. I again thank you for joining the session. So this session focuses on some prerequisite demo related to Palo Alto, PCNSE. So myself, Azad, and I have about 9 years of experience in the industry. I am a security SME in one of the MNC in India. So I'm into doing corporate and freelance training for about 5 6 years now. Um, so I'll be your trainer for this complete session. So this demo will be probably for about 1 hour to 1 hour 45 minutes. So I would also like to take your brief introduction before we get started with the session. I'll take walk you through the agenda on what we're going to do. We will keep it crisp and short to just understand what we're here for. Post that in the actual session, we'll go deep into the product Palo Alto, right? Okay, so if you guys can hear me clear, we can get started with some uh, introduction from your side. A brief introduction about your name and your role, what you're currently doing, and what's the expectation out of this course. So that will get us started with the agenda. So anyone would like to volunteer? Yes, guys, anyone would like to volunteer?
Hi, my name is Abhilash. I am working as a network
Hey, hi.
engineer. Yeah,
Mhm.
and I'm new to Palo Alto, and I just want to do what to say, at least make do a certification after this course. Uh, that's
Okay,
my
all right. Okay.
yeah. Thank you.
Okay, that's great. That's great. Thank you. Thanks a lot, Abhilash. Okay. Yeah, so that's something that I would like to hear from you people. So, anyone would like to talk after Abhilash?
Yeah.
Hello, good morning.
Yeah, good morning. Good morning. Yes.
My name is Zade.
Hey,
I'm a
hi.
network engineer and network security engineer as well.
Mm-hmm.
Um, PaloAlto looks new in our environment. It's equipment that is just being brought in.
Mm-hmm.
I'm always used to Cisco, Fortigate, and the like. So just joining this course to have a grasp of how the Palo Alto environment works, enhance my skill, and also see if I could get my hands on one or two certifications in that space. Thank you.
Yeah, thanks you. Thanks you. Thanks to you, Ade. All right. So maybe we can have a final few people to talk, and then we can get started. Yeah, it's practically not possible for everyone to have a go, but yeah, just I wanted to understand the gist of what your expectations are and where you're coming from. Yeah, so that's about it. Anyone else from the crowd?
Well, good morning.
Good morning.
I'm Vicent Ferran from Barcelona, Spain.
Mm-hmm.
I'm a network engineer specialized in Cisco CCNP Encore, and I'm new in Palo Alto, so I want to know this marvelous firewall.
Okay. All right. Uh, Thanks a lot. Okay, so we'll have it from the final one candidate, and then we can get started with this. Okay, and I hope you guys can see my screen clearly. You should see the lab topology that we're going to work for the session throughout. I'm just going to use a short part of the topology today for me to demonstrate something to you. In fact, we're going to do a lot of theory today, but at the end of the session, I thought I would show you a glance of how the firewall looks like, the look and feel of it, and we'll do a short lab on um, uh, some concept that I have in mind. So yeah, I hope my screen is clear. Let's get going. If anyone else would like to talk, you can, or else we can get started with the session. Yeah.
Yeah, hi, this is Sandeep here. So, can you give the walkthrough about like what is expected from this course, and I mean the line items which will be going through the course?
Yeah, so I'll talk about the agenda today. By the end of the session, I'll be sharing you the management will be sharing you the exact curriculum that we'll be going over. Yeah. So with respect to the agenda today, we'll be going over. Let me share that to you. Yeah. So this is what we'll be talking about today. So we'll start with for short comparison on what a router and a firewall is and what traditional firewall would do and an next generation firewall would do. And from there, we'll go over into the product PaloAlto. We'll talk about some features and use cases. And then we'll jump into the packet flow, and then we'll do a short lab on the firewall itself today from the topology that I showed you. So that will be the agenda for today. The course curriculum, yes, it will be shared to you from the backend team, from the management, probably by today while you get the recordings done.
Okay.
You'll also be getting the recordings emailed to you. So along with that, you'll be having the course curriculum as well for you to decide on what we're going to do today, do for the rest of the session with this course. Okay. Okay. So as I mentioned, the lab topology would look something like this. I'll be depending upon the topic that we're going to look at. I'll be breaking the topology. I'll be going away from this topology that we're going to use majorly. So we'll be walking you through the actual security features of Palo Alto, along with how the routing works in it, how the redistribution is done, how do you configure OSPF, how do you redistribute other protocols into this one. So the basic routing stuff that you do with the Cisco devices, but the main focus would be on the security aspects of it. Yeah. So we'll be working towards security policies and what exact security features that the firewall has. Apart from that, now we'll be going over some gist of how do you work on routing with Palo Alto and other features as well. So I'll be giving you a brief introduction about what are the use cases and features of the firewall, where you'll come to know what major topics that we'll be covering with this one. Yeah. Okay. All right. So I hope we can get started. Okay, let's first try to understand the difference between the router and a firewall. So when I talk about a product called a router, so which is something that you might have already uh, been using currently in your environment. Probably few might be new to the firewall, few might have been using a different flavor of firewall. But let's try to understand what a router or a firewall would do here. So when I consider a router is something which has an IP address. So it's a layer 3 device, as you know, which will have an IP address to it. On top of that, a router is something that does routing, which means it will be able to forward the layer 3 packet from one hop to another hop or from source to destination. Yeah. So that's something that the router majorly does. That's a major key aspect of routing on how it functions. Yeah. So apart from that, in terms of security, as we're talking about a security product, in terms of security, a router can do some a bit of security in it. where we could do something called as an access list. Yeah. So I hope everyone might have heard about access list. So we could do something called as a standard and an extended access list, right? So this is the maximum that we could do with a router. Yeah. So a router could probably do some advanced level routing manipulations, but when you talk about security, it could only do access list, which probably you might have already seen what a standard or an extended access list would do. Okay, so with respect to access list, the drawback is that you can only filter with IP addresses. Yeah, you cannot do advanced level filtering on your router, where you cannot understand what the application the user is using, right? What app what website he is basically trying to access. You cannot control the user from accessing a specific website or a specific application. Yeah, so that's actually the drawback of a router, in terms of security. So it can do any minimum security. You can consider that the router could do security, but in a very minimum level that you could say. Okay, coming to the firewall. Okay, let me directly talk about a next generation firewall. Yeah. Okay, when we talk about a next generation firewall here, a firewall could do everything a router could do. Yeah, that's the first thing that we are supposed to understand. A firewall is again a layer 3 device. It can also be configured as a layer 2 device. We will talk about a specific deployment of a firewall called a virtual wire, where we will not be configuring any IP address whatsoever on the device. The firewall will just be sitting in the middle, doing inspection, doing all the security stuff that it's supposed to do. Um, on top of that, the major thing to note there is it will not have any sort of IP address to it. It will not do routing. It will not do any IP address manipulation, but it will just do the analysis of what traffic goes through the firewall, and it will do some security stuff on top of it. Yeah, but in general, if you talk about a firewall, it is again a layer 3 device, right? So it does routing, right, like your router does. And instead of access list, we do something called as a security policy here. Okay, so it's not only that. So like your router could do NAT, right? So I hope you guys are aware of what NATing is. Router could do only probably about 2 to 3 types of NAT. Probably a port address translation, static NAT, dynamic NAT. Here in a firewall, you could do much more than that. We will talk about different NAT types when we talk about that topic in the session, but it could do some advanced level NAT, I would say. One such type of NAT that I can define would be U-turn NAT, bidirectional NAT, which is something that we don't have in your routers. Yeah. So when I compare a router with a firewall, this is something that is there in common with your devices. So I can easily compare your access list with respect to the security policy. What additionally do we have in a firewall? Can we expect on an next generation firewall is that it is a zone-based device, right? So we'll talk about what a zone is in a bit, right? So it's a zone-based device, which means each and every interface of your firewall, right? Each and every interface of your firewall will be defined with a zone, which is nothing but a name to that interface, right? You will group multiple interfaces to a single zone, which will help you to restrict or allow the traffic or control the traffic based on zones. So basically, for example, let me just pick this up here. For example, you have VLAN 10. This is for user data 1. You have VLAN 20. You have this is for Wi-Fi, right? You have VLAN 30. This is for floor 3 user LAN. So all these three are common users. They connect to the network in different ways, right? So let's say these guys are VLAN 10 is floor 2. Yeah. So this is floor 2 LAN users. This is floor 3 LAN users. This is Wi-Fi users, right? So all these three VLANs are user VLANs connecting from different locations, or using a different platform like a Wi-Fi or a LAN. But all these three should be having similar level of access. So if you're writing a security policy for you to allow a user to access a specific server, you got to write it for all the three users. So it's ideal for you to drop all of them in a single zone. So let's say all three are coming into the firewall with a sub interface. For example, VLAN Ethernet 1/1 is the interface that the traffic is coming into. Ethernet 1/1.10 is VLAN 10, dot 20 is VLAN 20, and dot 30 is VLAN 30. So you can put all of them in zone inside. And when you write a security policy, you could write them in such a way that a source zone will be inside, and the source IP address will be probably any, because you're mapping the traffic based on the zone, and you can allow or deny on whatever application you want to allow or deny. So it's basically grouping different VLANs or different interfaces according to how they function inside your network. Yeah, so that's called a zone, right? We'll go deep on what a zone is, how it's configured and everything, but for now just try to understand a zone is nothing but multiple interfaces coming into the firewall, multiple networks, multiple VLANs coming into the firewall. If they are capable of being grouped into a single no administration, you could do so with the help of a zone. Like I said here, VLAN 10, VLAN 20, and VLAN 30 all are nothing but user VLANs in different forms. You could group them in a single zone called inside, and you can impose a security policy based on the zone so that everyone gets the same access. Yeah. Okay. So I hope this is clear. Okay. So additionally, so I just spoke about a very minimum feature set here with respect to the firewall to that of a router, but there is more to it. We will be talking a lot more about the firewall features when I get to the agenda here, the PaloAlto firewall use cases and the features. So when I get to this one, I'll be talking about the actual core concepts of why a firewall is called a firewall. So why do you say that they are a next generation firewall? Yeah. So we'll be going over different key points on what a next generation firewall is and what are the features that are built into it, which a router cannot do at all. Yeah. Okay, that's how you compare a firewall with a router in a simple statement. So as I said, I didn't go deep into other features of the firewall. Apart from that, maybe I can group them into one single statement saying other next generation features, right? So with this, what I mean is, I mean to say URL filtering. I could say um, antivirus, anti-malware features, etc. Right? So we'll be going over into each of them later on in the session. Probably not today in detail, but later on in the session. But these are the major aspects of a firewall, which a router uh, cannot function, cannot do. This is a maximum that you could do with the router. Yeah. Okay. Coming to comparison about a firewall and next generation firewall. So I was talking about the next generation firewall here, or firewall in general. So when I consider comparing a next generation firewall with a normal firewall, so when I say next gen firewall, Traditional firewall. So I'll say the major difference is on which layer they work on. So which layer in the OSI model that they are going to function on. So when I talk about the traditional firewall, let me come back from here. They function on layer 4 of the OSI model. Layers 4, which is transport layer. Okay, sorry, I won't say that they function on layer 4. They function on layer 3, all both of them. They are a layer 3 device, but they inspect up to layer 4. Okay, so let me come back to the point on what is layer 4 inspection. But let me just write the comparison here with the next-gen firewall. The next-gen firewall inspects up to layer 7. Okay, so what do I mean by inspection? It basically inspects the traffic on that specific layer or up to that specific layer. So when I say layer 4 inspection, up to layer 4, from layer 1 to layer 4, the inspection happens on a traditional firewall. So which means you could filter or control the traffic based on up to layer 4, which is transport layer, which means you could control the traffic based on IP addresses like your router does. You could control the traffic based on port numbers and protocols. Okay, so layer 4 is what? Layer 4 is a transport layer which works on TCP or UDP, which is nothing but protocols and port numbers. Yeah, so your traditional firewall is capable of inspecting up to layer 4. Up to layer 4, by which what I mean is it can inspect layer 3, layer 2, and layer 4, which is MAC addresses. It can do IP address inspection. It can also do port numbers and protocol inspection. Okay, so that's why if you consider traditional firewall as an example, I could say that they're nothing but an ASA. So okay, I can take an example of an ASA here. So if you've worked on an ASA firewall, which is a Cisco product, you see that when you write a policy, when you write an access list or a security policy or an access list, you will be able to write an access list by filtering IP addresses, by inspecting layer 4 protocols and port numbers, right? You cannot do much more than that. So you cannot go beyond layer 4 and inspect anything advanced after layer 4 in an ASA, right? So that's why we say a traditional firewall is capable of inspecting up to layer 4, which is transport layer. Okay, coming to a next-gen firewall, it can inspect up to layer 7, which means it could do everything that a traditional firewall could do. It could inspect up to layer 4, layer 3, and layer 2. And it could also go one step forward in inspecting layer 7, which is an application layer. So this is where your firewall gets intelligent in inspecting and analyzing what exact application that the user is using. So when I talk about an application, it is nothing but talking about what exact uh, application that the user is actually hitting at the end. So when, for example, if a user logs into Facebook here, he's basically trying to initiate an SSL connection, right? HTTPS connection by not going to Facebook or any social media application or any website. After that, he logs into the application using a username and password. So your firewall here, next-gen firewall here, is capable of inspecting up to layer 7, which means when a user hits https facebook.com, it identifies the application to be SSL first. And after he logs into the specific application using the username and password, it then identifies that he's actually using Facebook. So it identifies the application on every level of his access, right? So it is capable of identifying the end application that the user is trying to use or trying to access, right? So that is what you call it as layer 7 or application layer level inspection. Okay. Okay, apart from that, what other uh, consideration that we could have with traditional firewall and your ASA, traditional firewall and next generation firewall? Your traditional firewall cannot do anything more than layer 4 inspection, which means it cannot do antivirus scanning. It cannot do anti-malware scanning. it cannot do anything more than layer 4 inspection. So it could only inspect up to layer 4. The one common consideration that we could say with respect to your traditional firewall and a next generation firewall is both are stateful firewalls. Okay, let me write it down here. So both are considered to be a stateful firewall. So what do you mean by a stateful firewall? Okay, let me talk a bit about this one before we move into the next agenda, which is firewall use cases. So I'll not be talking too much into details of this one. I'll just be listing down a few features and I'll be talking a one-liner about it, which will probably make you understand what exactly it is, how it's configured, how it actually works inside. We'll take it to the next upcoming sessions, right? So for now, let's try to understand what a stateful firewall is. It's very important for you to learn any firewall, not only Palo Alto. So let's say, for example, we have a firewall. Let's say this is a Palo Alto, all right? Or any firewall that does a stateful inspection. So if you consider any recent firewalls, by default, they come with this stateful inspection feature. So let's consider this as a firewall Palo Alto. And let's say there is a user who is sitting behind this firewall. Of course, there will be switches and other network devices, but I'm just trying to consider guys, can you hear me? I just wanted to know if I'm audible.
Yes, 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 sir.
Okay, am I? Okay, thank you. Just give me 1 second, guys. I think my screen has some problem. I'm not able to click anywhere. Just give me a minute, if you don't mind. Okay. All right. Okay, I hope my screen is clear now. Okay, let me pick up user behind this firewall. Right? Let's say there's a user sitting behind this. So let's imagine that this user wants to reach somewhere in internet. So let's say this is your server in internet. Okay. Okay, considering this is the short topology that I have. So user wants to hit a server at internet, for example, YouTube, or he wants to go to any website or whatever. He is supposed to go through the firewall, right? So when I talk about a stateful inspection, I'm linearly connecting this with the security policy definition, right? So when you define a security policy, it is enough for you to define the security policy um, one way. For example, the user trying to hit this server. So it's enough for you to define a policy in this direction where a user, let's say he's coming from an inside zone, right? And this is an outside zone, right? This is inside zone and this is the outside zone. So it's enough for you to define a policy from inside to outside and with the respective IP addresses or email your URLs or whatever. It's enough for you to define the traffic or security policy in one direction. The return traffic is automatically allowed by the firewall. Okay, so for the connection to successfully happen, it's required for a user to hit the server and the server to respond back. So when I try to hit youtube.com from here, let's say I'm hitting youtube.com. So the page opens here. It's because I'm initiating a connection from my PC and it travels across the network and hits the youtube.com server and I get a response back to my PC. And that's when I get this youtube.com page, right? So when you talk about a space stateful inspection, it's enough for you to start writing a policy in one direction, in the actual direction where your user tries to hit the server. The return traffic, the response traffic from the server towards internet, server towards the user, is automatically allowed by the firewall. The reason why it does so is because the firewall maintains something called a session table. So every time there is a traffic that gets initiated, the firewall has a session table where it will maintain something like session number 1. Source is 10.1.1.1, which is the IP address of the user. Destination is youtube.com. Application is SSL. Right? So it will maintain something like this in the session table. And when you have allowed a user to hit the server in the internet in this direction from user to the server, this session gets created in the session table. And when the return traffic comes back from the server towards the user as a response to get this page, it's automatically allowed by the firewall because it's stateful, because it maintains a session where I have already created a session for this user to hit the youtube.com and I'm getting a response back from the same server towards the same user. So I'm going to allow this traffic. Okay. So you should not misunderstand this to be a case where if a server himself initiates a connection, for example, if a server wants to talk to the user, I'm not talking about a YouTube server here, it could be any server. If this server wants to talk to an internal resource, he is actually initiating a connection. He's not responding for a connection initiated by the user. Okay. So in that case, the condition is different. You got to allow the traffic between the initiator and the responder, right? Which means you got to allow the traffic between the server and the internal resource, which is a user here, for example, right? So I'm only talking about the response traffic is allowed by default because the firewall is stateful. Okay. In this case, a user tries to hit the server, a session is created, and when the server responds back for the same session, that is allowed by the firewall because it's stateful. On the contrast, if a server is initiating a new connection, hear me clearly, if it's a new connection from the server, if he is trying to talk to the user, if it's a new connection, then you got to have a policy that allows the traffic from the server towards this user, and the return traffic from the user to the server will be allowed by default, right? So the condition of stateful inspection is only applicable if the response comes back from the server is for the same connection that you're trying to allow the traffic for the user in one direction. So if you allow the traffic in one direction, the return traffic is automatically allowed, right? For the same connection. Okay. If a server initiates a new connection, then the case is different. You got to allow a traffic, allow the security policy from the server towards the user, from source to the destination. for the traffic to be allowed. So it's in other words, if you could put it this way, you consider the guy who is actually starting the traffic or initiating the traffic as initiator, and who is going to respond as a responder. Always you should be making sure that initiator to responder is allowed on the firewall through a security policy. Responder to initiator for the same connection is allowed by default by the firewall, right? Initiator to responder is our responsibility. Responder to initiator is taken care by the firewall because we have a session created on the firewall. Okay, so that is what you call it as a stateful inspection. So which is something that we have in common between next generation firewall and a traditional firewall, right? Otherwise, traditional firewall cannot do much more than inspecting up to layer 4, which is protocol and port number inspection. Next gen firewall, it could do much more than that. We are going to take a look at it next when we talk about the firewall use cases. Okay, I hope it's clear so far. Any questions so far? Would you like to ask out anything before we move forward?
Hi, Asad. So
Yeah.
you told you told right. So in traditional firewall also we can like any checkpoint we can use like user filtering. Sorry, URL filtering, right? Apart from
No.
using.
In traditional firewall, we will not be able to inspect traffic based on URLs. We will be only able to inspect up to layer 4. So when you talk about URLs, you're talking about application, right? You're talking about
Yes.
SSL, right? So when
Yes.
you talk about an application level traffic, you cannot achieve or inspect or do any manipulation with it or do any control. You will not be able to have any control over it when you're using a traditional firewall, which is ASA. In ASA, you will only be able to control traffic up to layer 4, which is you could filter traffic based on what source the traffic is coming from, what's the source IP or source network, destination IP or destination network, what is the protocol or port number. So that's the maximum that you could do with a traditional firewall. But whereas
Okay.
in a
So
next generation firewall, you could say that, for example, if a user wants to hit facebook.com, your condition doesn't stop there. You can even say that he can only use Facebook chat. He don't he cannot use Facebook video, or he cannot use a Facebook not timeline. No, you could say what sub application inside the main application the user can use. So you could go up to that level in controlling your
yeah,
application.
I understand. Yeah. So
Yeah.
we can give you some restriction on the next layer. Okay.
Yeah, exactly. So that's how much you can control with the help of an next generation firewall, but you cannot even think of it in traditional firewall because it only inspects up to layer 4. So if you consider layer 4, as you know, it only works, or you can only play with protocols and port numbers.
Yeah, okay. Thank you, sir. Thank you.
Yeah. All right. So with that being said, well, let's go forward in talking about the next agenda, which will be the firewall use cases or features. Okay, so there are a number of features that we have, every quarter, uh, especially Palo Alto is evolving themselves with, multiple features that they're bringing into either it could be a software level feature or a hardware enhancement. Now we'll talk a bit about, what do we have to know importantly as a feature in Palo Alto. Now, what defines this firewall to be a next generation firewall? Yeah. So when I say Palo Alto next gen features, as I already mentioned, I can think of this to be a zone-based firewall. So the concept of zone is something that you probably have only in a next generation firewall. It is there in probably every firewall that is claimed to be a next generation firewall. So the competitors for Palo Alto, if you see, they are Checkpoint. You have Cisco FTD. Checkpoint, you have Fortinet. Fortinet is a strong contender along with Palo Alto. But Palo Alto takes an edge over Fortinet in terms of the user experience as well as the stability. Yeah. So and also with respect to the customer service, personally, I feel Palo Alto takes an edge over Fortinet. So yeah, as I said, zone is something that you can think of first when you talk about a next generation firewall. I spoke a bit about the zone already. So on top of that, we could say URL filtering, which again we spoke about. There is much more to URL filtering. No, you can even filter the traffic. No, let me come to that. Let me just define um, the features, probably about 7 to 8 features, and then we can take a definition of each one of them to understand what they are. Okay, we have a feature called as user ID. I did not get into, uh, I'm not going to go into deep details of how things are configured and stuff, for which we will not have time today. But no, I'll just be going over what is what sort of definition here on each one of the pointers that I'm trying to define here. Yeah. So user ID is one of them, and we have a series of content inspection features, which are nothing but antivirus, anti-malware, spyware, anti-spyware, etc. So these are all content inspection features. Most important one is wildfire. We will take some time with this one. Sorry, I meant to write wildfire. All right, what else? Okay, I'll also talk a bit about deployment modes because when you think about a traditional firewall, you don't have as many as deployment modes that your next-gen firewall, especially your Palo Alto has. So I'll also take an opportunity to talk a bit about different deployment modes. This is not directly related to security, but I'll just add this to the features that the firewall has. Okay, so let's just get to each one of them. I hope I have spoken about zones already. Okay, URL filtering again, it's not only about defining or controlling the traffic based on a specific URL. For example, you could group, let's say you want to allow 4 URLs for a user for him to access. It's not just about URL filtering is not just about allowing, let's say I'm allowing YouTube, Facebook, Instagram, and all the social media applications for some group of users in the company. It's not the user URL filtering is not just about that. It's also about grouping the URLs based on category. So the Palo Alto themselves have grouped the URLs based on a certain category. For example, social media. Okay. They might have. I'll show you that when I get to the firewall. When I log into the firewall and when I try to show you the dashboard. Now you can group the URLs based on a specific category, and you could impose that category on the security policy for you to allow the traffic, on a category basis. So you could say that all the social media category applications are allowed for these and these VIP users. Okay, for normal users it is not. Okay, so you could do so by availing the feature of grouping the URL category that the firewall has it pre-built into the firewall. The Palo Alto has it pre-built into the firewall. You could use that and you could impose it onto the security policy and say that for this specific URL category, you will be able to uh, allow them for these set of users. Okay, let's just try to understand that by looking at the firewall later. Okay, we'll talk about user ID and other features before we get to the firewall. Yeah. So when I talk about user ID, this is something that your traditional firewall doesn't have. So let me try to explain what it does here. So when I say user ID, you know that you will have your LDAP servers or your Active Directory servers, which will be used for maintaining the user to IP databases, right? So your Active Directory servers or LDAP servers, the databases that they have about the users on the username to IP mapping, you'll be able to integrate them with the firewall. So for example, let me take a moment to draw this down. Okay, so as you know here, we have the LDAP server will have username to IP mapping. Okay, so this username to IP mapping database can be integrated onto the firewall or can be copied to the firewall by integrating your LDAP and your firewall with some basic configuration. We will be doing this lab extensively on how it's done. But in short, your LDAP server will have username to IP address mapping within it. This database can be inherited or copied onto the firewall by integrating your firewall and LDAP. And once this username to IP mapping is on the firewall, you could use this information, you could use this database information for you to impose it onto the security policy and say that for this specific user, I'm allowing this application, or for this specific user, not with the IP address, but with his Active Directory username, right? So you'll be able to use his Active Directory username and allow the traffic based on a specific user or specific group. So you can also inherit the not only the users but also the Active Directory groups into the firewall, and you'll be able to use those groups inside the security policy to control the traffic. Okay, so you don't really have to have the hassle of using IP addresses to control the traffic on the security policy like you do with ASA. You could also be able to use the Active Directory groups and Active Directory usernames for you to filter the traffic via the security policy. And on top of that, one more use case here indirectly would be that your uh, traffic logs that you see on the firewall will also be having the information about which user is this traffic coming from, or which group of users this traffic is coming from. Okay, that is also going to be one additional advantage for you to easily troubleshoot on which user is using this traffic. For example, you're getting complaints that your internet is slow. When you go check your internet connection, your bandwidth is being choked. Someone is overutilizing the bandwidth in your company. And for you to analyze which application is overutilizing, you have your dashboards available in the Palo Alto. You're checking, and if you don't have this user IP mapping integration, you will only be able to see that this IP address is using so and so bandwidth. You'll not be able to exactly catch on which user he is. But with the help of this one, you'll be able to exactly identify that this specific user is overutilizing the bandwidth, and you can probably go and give him short sign of this is something that we are supposed to do because it's impacting other users, right? So this feature is very useful when it comes to identifying which user is using what application or what traffic, and also to control the traffic based on the users and user groups. Okay.
Hello, hi Asad. So
Yeah.
you are saying this user IP mapping is nothing but like creating object or creating group like.
We are not going to create anything. So as I mentioned, your Active Directory or LDAP server will be located somewhere in a data center. right? Your
Yes.
LDAP server will have this information of username and password. So if you're
Yes,
working in a
correct.
multi organization, you will be logging in using your AD username and password. Nowadays we are having only one username, one password login for everything, right? So your LDAP server will be connected using some configuration. You'll be connecting your LDAP server. It'll be syncing your LDAP server with your firewall, and the firewall will just copy all the database information about username and IP address mapping to the firewall. And with the help of that information, you should be able to achieve this username based security policy creation, and you'll also be able to view the logs based on the username.
Okay, okay, thank you. Yeah, sure.
Yeah, we're not going to configure anything on your firewall. Rather, it's already there on your LDAP. You're just syncing your LDAP with your firewall. And once the sync happens, your database information will be copied onto your inherited onto your firewall, and you'll be able to use that to achieve this security policy implication.
Okay, okay, yeah, got it. Thanks.
Yeah. Okay, so that's about user ID mapping. So I'm not going to go in details about antivirus, anti-malware, and spyware. So you know what a virus, malware, and spyware is about. It's just about creating a certain policy and a certain profile, and adding them onto the security policy, so that if the specific uh, if a specific user is trying to hit a virus file, or if he's trying to download a spyware or a malware, he'll be able to we'll be able to control him based on what actions we take if a certain spyware or malware file is being tried to download, or if he's trying to download something or access something. Okay, so we'll get into details while we do the lab here, and we will also not be able to achieve 100% lab on this one because it requires a paid license, but I'll try to get this achieved using an AWS deployment if possible, depending upon the time constraints that we have. But let's go on to the wildfire here, which is very important. Let me probably try to take a diagram for me to better explain this one from internet. Okay, wildfire is a feature which is something that the Palo Alto uh, provides us, where it's basically told to be a feature which is used to avoid zero-day attacks. So what do you mean by a zero-day attack? When there is a specific attack that you are noticing which is not being noticed before in any environment, that's what you call it as a zero-day attack in your security portfolio. So when there is a specific attack that you're seeing for the first time, that's called a zero-day attack. So how does a firewall avoid that being happening, and how does the firewall prevent that from being happening, or from being multiplied onto your network further? Okay, that's what a wildfire does. Okay, let me try to take a simple diagram here. Maybe this one would do, I guess. Okay, or else let me just consider drawing it myself. No worries. So let's say we have a firewall. So let me just complete the diagram. Bear with me for a few minutes. Post that, we'll try to discuss on what. Okay. All right. So let's consider that this is the setup that we have. So basically, you have an attacker. Let me not do this. Guess. Yeah. So we have an attacker in the internet, and you have a firewall, and you have a user who is sitting inside, and you have a Palo Alto cloud that we'll be using in this specific demonstration. So, as I mentioned, Wildfire is a feature which is used for avoiding your network from being infected from a zero-day attack. So I explained to you what a zero-day attack is, which is nothing but an attack which is not being seen before or not being experienced before in the security environment, from any organization or from anywhere in the world. Yeah. So let's say that there is a specific, a phishing email that a user is getting, and he's trying to hit that email, the URL inside the email, and he's trying to download a file, which is something that's not supposed to be downloaded. It's a virus or a malware file. And once the user all this happenings are being passed on through the firewall, the user trying to hit the URL, and he's trying to download a file, everything is going through the firewall. Yeah. So while everything is happening, the firewalls calmly notices this, and when the file is being downloaded by the PC, this PC gets infected. Yeah. So when it's a zero-day attack, from it being happening to one specific user, before that your firewall cannot prevent it. Yeah. So the first user who's trying to hit that specific malware file or a virus file will get impacted. But while that happens, your firewall will see that something is fishy with this download, and it sends the traffic. It tries to inspect that with the available threat IDs or threat information that it has. If it is not finding anything that is a known that has that to be a known threat, it sends it to the Palo Alto cloud. Okay. So in the Palo Alto cloud, you have something called as a Palo Alto sandbox. Sandbox is nothing but a testing environment. Yeah. So before you deploy something in production, you test it with some lab or something in your infrastructure, isn't it? So some companies have it. Some companies will have a lab environment where you test few things before deploying it in production. Similarly, your Palo Alto cloud has something called as a sandbox. This sandbox will be available in the Palo Alto cloud, and the firewall will send this specific traffic, that's the file that's being downloaded by the user, to the Palo Alto cloud, and the sandbox here will pretend itself to be a user, and it will try to initiate a connection to the attacker website that is sitting over here. So let's say, for example, yeah. So the sandbox will so once the firewall identifies that there is something wrong with the file being downloaded, it sends that file to the Palo Alto cloud for inspection. Before sending it, it will check its internal threat database to see if this is a known threat. Okay. If it is not a known threat, the wildfire signatures, the wildfire feature will send the file, the file that the user downloaded, to the Palo Alto cloud, and the sandbox inside the Palo Alto cloud, which is nothing but a testing PC, test PC, it will initiate a connection. It will hit the same URL that the user hits, and it will try to hit the attacker URL to download the same file. And this file, once being downloaded, will be inspected by the Palo Alto cloud, and it will flag this to be a legitimate traffic, or it will flag this to be a threat based on what type of traffic it is. So it's basically this second set of accessing this attacker URL is done for basically identifying if this is indeed a threat. Yeah. So until this point, the firewall or your Palo Alto cloud doesn't know if this is actually a legitimate URL that the user accessed, or the legitimate file that he downloaded, or if it's a threat. Okay. To identify that, they do the action again by downloading the same file again, by accessing the same URL again, and this time they do it for inspecting whether this is a legitimate traffic or not. Okay. If this file is found to be a threat file, then a threat ID will be created for that specific type of traffic, There'll be a threat ID that the firewall, the Palo Alto cloud would create. And this threat ID will be passed on to not only this firewall, but to every other firewall which has a wildfire subscription active for that serial number of the firewall. So let's say, for example, you know, uh, there are so many customers for Palo Alto in across the world, right? So everyone who has this wildfire subscription activated for their firewall serial number, everyone will get this information about this threat that was identified by the Palo Alto cloud through this testing phase that they did. And this threat ID will be updated onto the wildfire signatures of the Palo Alto firewall, which has of every Palo Alto firewall which has a wildfire subscription. Okay, this happens within 5 minutes of time. Whoever has a wildfire subscription, they'll all get this information. They'll all get this update within 5 minutes of time. Whoever doesn't have this wildfire subscription, if they do have a threat license, they'll be getting it within 24 hours of time. So it's not that people only the firewalls only which only has a wildfire subscription will get this information. They get it a little quicker. They get it within 5 minutes of time after this being identified. But whoever doesn't have a wildfire license, but if they have a threat license, they'll be getting this information within 24 hours of time from the time that this being identified, right? So in this way, uh, this one PC gets infected because he already downloaded the file, but it will prevent the whole world from not being impacted with this type of attack by identifying that this is a threat using a sandbox from Palo Alto Cloud, right? So this is how your wildfire works. Okay, this is very important when it comes to knowing how it works and also in implementing them. Implementing them is very easy. It's just about creating a profile and attaching it to the policy. But knowing how it works is very important, right? Okay. Next, you have application level inspection, which is again inspecting the traffic based on the application. I've already spoken about it. I gave an example of you accessing a Facebook URL from your browser. Initially, it identifies the application as HTTPS because you'll be saying HTTPS facebook.com. And after you enter into the Facebook website, it identifies the application as Facebook. And then if you enter a chat inside Facebook, it identifies that to be a Facebook chat or Facebook video or whatever it is. Okay, so it basically identifies the end application of your of the user's traffic. Okay. Okay, then comes your deployment mode. This is again something that I have nothing to do with your security feature, but I thought I would talk about it as a general feature in Palo Alto. So when you talk about a deployment mode, you could deploy the firewall in probably three ways now. Earlier it was only two, but recently we have one more type of deployment that we have come across. So we have a standalone deployment where we configure the firewall as a standalone device, which means if you have 50 firewalls in your company for 50 locations, you will have to log into each and every one of them to configure each of the firewall, which means you will not have a centralized management console for managing all the firewall at once, right? You will have to know all the 50 firewall IP addresses to log into each one of them to do the changes on each one of them, right? So that's a standalone deployment. And to be frank, any medium to large scale companies would not do this. They will go for either second or third option, which is Panorama and Strata. Okay, so Panorama and Strata pretty much they are one and the same. They are basically going to do the same job, but Strata is a little advanced in terms of how it works. So let me talk a bit about Panorama and then come back to Strata. Okay, let's say this is the firewall. Okay, so let's say this is a Panorama appliance. So this Panorama appliance can be a software, which means it could be a virtual firewall, virtual device, or it could be um, a physical appliance as well. But most probably this will be deployed as a a virtual device. So let's say we have about 20 firewalls that we're supposed to manage. I'm having hard times with this. Give me a second. Okay, let's say these are, let's say we have 20 firewalls. Okay, let's say this is a panorama. Okay, so it's ideally about managing all the 20 firewalls through one management console, and Panorama is nothing but a management console which you log into it. Initially, you will have to make sure that you are connecting your firewall to the Panorama. Once the firewall is connected to Panorama, you'll be able to manage all the 20 firewalls. Inside the single management console, you'll be able to push the configuration in bulk. Let's say, for example, you need about 5 policies, which is common for all the 20 firewalls that you need to push. If you're not using a centralized management console like Panorama or Strata, you will have to configure all of them in all 20 firewalls by logging into each one of them individually, right? It's going to be a time consuming task, and obviously you might be making some mistake since it's going to be repeated. You could make some human errors. Yeah, so you could configure all of them at once in single shot on Panorama, and you can push it to all the firewalls at once for all the 20 firewalls at the same time. Yeah, so that's the actual advantage of using Panorama, and we'll be talking about talking a little bit about the device at the end of the session, which means not today, but end of the actual course. But so I'll not be going deep into how it works and what are the key aspects of it today. But for now, just understand that Panorama is a centralized management console used for managing the next-gen firewalls alone. So when I say next-gen firewalls alone, Strata could do much more than that. So when I just replace this with Strata, Strata pretty much does the same thing. Yeah. So what is the difference between a Strata and Panorama? Panorama can only work with next-gen firewalls. Strata also works with SASE products. If you're not aware of what a SASE is, it's nothing but SD-WAN and SD-WAN plus security stack in the cloud. So I'm not going to details of what a SASE means, but it basically supports more products than next generation firewalls for you to manage within the same console. And it's a cloud-based solution, which means you can access them directly through internet, and you could just integrate them with your Palo Alto customer support account, and you'll be able to log into them just with an internet connection. You don't really need to have a private IP address to it. It's just charter.paloaltonetworks.com, and you can log in using your account, and you'll be able to um, manage all the firewalls, all the SD-WAN appliances, other products as well within the Strata, whereas your Panorama can only manage your next-gen firewalls within it. Yeah, that's a major difference between your Strata and Panorama. So Panorama is going to be a private appliance that you will have within your environment. Strata is a cloud-based service where you will be using a public URL for you to log in using your account information, username information. And once you logged in, you'll be able to see all the firewalls that are part of your account, and you should be able to manage them from there. Yeah, it's not only the firewalls, but also other products in Strata that you can manage with the help of Strata. Let's say you can say next-gen firewalls. You could also manage SD-WAN ION devices. Yeah, you can also manage Prisma Access Solution. I have to say this to be Prisma SD-WAN. Yeah, and much more. So you can also manage Cortex. So there are a lot of products that you have inside Palo Alto that you can manage within this data console. But with respect to Panorama, it's only going to be your next-gen firewalls. All right. Okay. So let me walk you through the next in the list of agendas. We have packet flow sequence in Palo Alto. Okay. Again, I'll not be going into details of each and every thing here, but I'll make sure that you guys are getting the idea of how your packet flow works inside your firewall with the help of this diagram. Okay, this is your official Palo Alto link, which I can provide you, or you could just search for Palo Alto packet flow sequence. You'll be able to get to this page. Okay, let me take this a little quicker. I think we have only about 20 minutes, 30 minutes left. Okay, so this Palo Alto firewall works with about 5 stages before it processes a packet, gets the packet inside it and lets it out from the device. No, in between that process, it has about 5 stages. One is ingress, egress. In between ingress and egress, you have session setup stage, fast path, and application identification, a content inspection, right? So ingress stage is nothing but it basically collects some basic information about the packet, the source interface, the source zone, the MAC address of the receiver. Once it collects the basic information in the packet ingress process, it then checks if it's an IPsec tunnel packet. Because if you know if it's an IPsec tunnel packet, it should have an IPsec header inside which it will have the actual original header of the source information. Yeah, it then checks if it's an IPsec packet or SSL packet. If it's an IPsec packet, it decrypts the IPsec packet to know what's inside the IPsec packet, and then goes over the process again. And once that is done, it goes to session setup stage, fast path, where it wants to know whether it's a new session or it's an existing session. As I said, every connection that a user tries to make, every traffic that goes through the firewall, it will uh, create a session in its session table. So if the firewall identifies this to be a new session, it goes on to firewall session setup stage to set up a session. If it is a already existing session, let's say for example I have accessed youtube.com just 20 minutes before and I'm accessing it again, it's not a new session, right? So it's an existing session that the firewall has already seen. So in that case, it will continue with the fast path. If not, if it's a new session, brand new session, it is going to create a new session by getting into the session setup stage, right? So let's consider it's a new session. Let's consider it's a new session. The firewall basically will set itself up for identifying what's the next hop IP address, what's the routing mechanism being used and everything. For that, it needs to know what's the egress interface. It checks the routing table. Forwarding lookup is nothing but routing table. It checks the egress interface, egress zone, and what's the layer 3 route that it has. After that, it checks if the NAT is applicable for the traffic. It only does a lookup here. Lookup means it only identifies whether there is a NAT applicable for this traffic or not from the source to this destination if we are supposed to do NATing, right? It checks the NAT policy. And then finally, it checks the security policy. And in this case, at this stage, it doesn't know what application that the user is using. Okay, it has not identified the application, because application identification session is going to happen over here, right? Over here, this is the stage where your application is being identified. But at the initial stage, it doesn't know what the application is, right? The firewall doesn't know what the application is. So it keeps the application section as any, and it just checks across the security policy with other parameters like your source IPs, destination IPs, source zone, destination zone, protocols, port numbers, and everything. Okay, it does not. It just keeps the application as any and checks other aspects like zones, IP addresses, protocols, port numbers, and sees if there is a rule match. Okay, if there is a rule match, it creates a session and it goes on to fast path. In the fast path, it actually implements the NAT here. As I said earlier, in the slow path, that is session setup stage, it looks up for the NAT. Here it implements the NAT. It actually does NATing, right? It NATs the traffic, whether it's a source or destination. It NATs the IP address from the original IP to the NATed IP. And once the NAT is done, it checks if it is an SSL traffic. Okay, if it's an SSL traffic, it decrypts the SSL to see what is inside, if there is a decryption applicable. So one of the features that I did not mention earlier of Palo Alto was that it can do SSL inspection, right? SSL decryption. Okay, if you are using, say for example, you are accessing a web page which is an SSL web page, HTTPS web page, if required, you will be able to inspect or decrypt the SSL traffic, right? You should be configuring a policy for that, so that the firewall will consider inspecting or decrypting that SSL traffic to see what's inside, not to see if it is a legitimate or if it doesn't have any virus or any suspicious activities going on inside the SSL, right? If you're not doing a decryption on SSL, your firewall will not be inspected. Your traffic will just go down as an SSL traffic. Whatever is happening inside SSL will be encrypted and you will not be able to see anything. If you would like to decrypt something which is an encrypted SSL traffic, you should write a policy for that and the firewall will be decrypting it for you. But you should be careful here, because you cannot just decrypt everything that is SSL, because SSL is something that the user uses day in, day out. Okay, every website that I'm hitting here is an SSL website. So the firewall uh, should only be asked to decrypt what is required, only which is important, not everything, because it will it will overdo the firewall CPU, and you'll not be able to proceed further with the firewall will not be able to proceed further with other aspects of work that is supposed to do, right? Okay, so apart from this, I would consider. Let me just zoom out 1 second. Yeah. So apart from this, the firewall goes over a few pattern-based application identification to identify the application which a user is using. No, they have not, the Palo have not provided any details of what it does, what actually is happening behind the scenes here on how the application is being identified. It only says that based on the pattern of application, for example, if it is HTTP, you know that the first packet of HTTP will be HTTP get message, then put message, and you will be exchanging some data, and then you will be terminating the data, terminating the connection. Okay, similarly, each and every application will have its own pattern. Based on the pattern, the application will be identified here, and again, the security policy will be looked upon. As I mentioned earlier, in the slow path, the security policy will be looked up with application as any. Here, once after the application is identified, it will again check for the security policy if the traffic is allowed for that specific application, right? So if it is allowed, it again goes on to check the content inspection, where it checks your policy across your anti-malware, anti-spyware, wildfire, and all the other content inspection policies. And based on the action that is taken, it will either alert the user, or it will deny the traffic, or it will block the traffic, right? And finally, here, if we have done SSL if you have done SSL decryption here at the top, so if you see Here, if you have written a policy for decrypting the SSL traffic, we will again re-encrypt it here before we move on to the egress path, right? So once after the re-encryption is done, the firewall will use the egress interface identified and it will let the traffic outside before, give me 1 second, before it lets the traffic outside. If it is a tunnel traffic, as you know, we might have done some decryption here. If it's an IPsec tunnel traffic, to see what's inside the IPsec tunnel. Similarly, at the egress stage, we will re-encrypt the tunnel traffic and then we will let the traffic outside, right? So the main key point to note here is ingress and egress happens automatically. It is not going to drop or block anything with respect to ingress and egress. The most important point to note is if it is a new traffic, new session or an old session. If it's a new session, it goes on to set up a session using this slow path. If it's a old session, already available session, it's going to hit the fast path and it's going to do NAT and then do application identification and content inspection before it comes to egress stage. Okay, so that's in short on how your packet flow works in Palo Alto. We'll get into details of what each and everything would do. For example, here we have a section which says firewall inspection applicable or not. On what basis, on what sequence are we considering if the firewall's inspection is applicable or not, which is provided in this documentation. We will go over this in detail in our actual session, which is provided here in a table. Yeah, over here. Okay, we'll get into details of this one later on. But for now, I hope you guys have understood on how uh, the traffic flow works inside Palo Alto. Yeah. Okay. So we'll take about next 10 minutes to do a short lab on your firewall. Now, while you deploy a new firewall, uh, your default username and password would be admin and admin. And at your first login, it will ask you to change the password. And once you change the password, you should be able to use the same password throughout. You could create new accounts, new administrator accounts and stuff inside the firewall once you log into the GUI, or you could do it in CLI as well. So let me log into this firewall with the IP address I've got. I'll explain you guys on how the lab works and what's the funda behind the lab and how we're getting the IP automatically from DHCP and everything. Now when we get to the session, the actual session from next week. So let's just log into the firewall now, 172.16.24.6. Okay, here again, as I mentioned, the password change is not going to be applicable for your GUI. For your GUI, you again have to change the password. So it is going to ask you for the old password, which is admin. And the new password, I'm just changing it to whatever I would like to. So this is your bootstrap configuration. You don't have anything. Okay, been logged out. Let me just see if I can log in again. Yeah. So once after I change the password, I should be let in with the new password. Uh, So I'll also be talking about how do you actually configure a firewall from the scratch. For example, I can easily teach you how a security policy works, how NAT works and stuff. But when you got to deploy a new firewall, what steps you could actually take? What should be your approach towards building a firewall from the scratch? Many of us would face a challenge on how to actually set up a firewall and bring it up to life when it is brand new. When it is just out of the box. Now we'll also talk about that in the session. Uh, now we'll be talking about a lot of insights on how practically you should approach in configuring a firewall. They're not just about, going to the firewall policies, configuring policies and say that this is working. Okay, so let's try to discuss about how a firewall GUI would look like. What's the look and feel of it? Now, if possible, I'll just show you how um, uh, a username and password can be created and password policies can be created before we finalize the session today. Okay, this is going to be a dashboard, and here you will have all the basic information about your firewall, like your username, sorry, the device name of the firewall, host name, the management IP address, uh, subnet mask, gateway, and your serial number, model number, and all your license level information. And more importantly, your system resources, which will say that what is your management CPU and your data plane CPU. Data plane CPU is nothing but what traffic flows to your data port, and this is what traffic that is coming into your management interface. Okay, what number of sessions are currently active? Currently, there is nothing because I haven't activated any of your data ports. So, what are the administrators who are logged in? Admin is the username who was logged in, and this is the IP address for him, and he is idle for 0 0 seconds because I am using it currently. Okay, so this is the basic information about your firewall. You can add more widgets as well, according to what you require or what you do. Okay, ACC monitor is your graphical representation of your network activity. You could probably see something over here if you have something happening on your firewall. Currently, we do not have any configuration, any traffic running through the firewall, so we will not be able to see anything here, but we'll try to go over this one later on. Monitor tab for you to view some logs. Most probably, in my experience, I would be using the first 4 logs here: traffic, threat, URL filtering, Wi-Fi submissions. And I'll come down to the system logs. I'd be using system logs here. Apart from that, others are not much of use. At least I have not used them much. User ID probably sometimes for you to troubleshoot anything related to user ID. Okay, so traffic log is nothing but a simple log file that you see here for users traffic. So when a user tries to hit something, hit a URL, the traffic log will be logging it over here, which you can see what parameters that you have from zone to zone, what's the source IP, source user. As I said, when a user ID is integrated, you'll be seeing the username of the user over here, which will be helpful for you to identify which user is actually doing what. Okay, so this is related to threat, URL filtering, and wildfire. Okay, similar type of log, right? Source address, destination address, source user, and everything. Okay, this is basically related to log. And as I mentioned, for each and every connection, the firewall will create a session and it will be available inside the session browser. Yeah. So you should also understand only after creating a session, and if a session is completely formed, you will be seeing them in the traffic log, right? If the session is not completely formed, if a TCP session is not completely formed, or if SSL session is not completely formed, you will not be seeing them inside the traffic log. So for the traffic log to display the logs, your session should be completely available. Yeah, you got to understand that. Okay, apart from that, these are report generation. I have hardly used them. If you would like to go over this, just you can take a look at it. We'll quickly move on to policies tab. So the first one in the list is security policy. You will have 2 default policies. One is intrazone and interzone policy. Intrazone means if a traffic is coming from zone A and going to zone A again, if it's the same zone traffic, that is intrazone, it's by default allowed by the firewall, which means if you got to deny the same zone traffic, you got to create a policy on top of this. Yeah, so by default, same zone traffic is allowed by default. The source and destination zones are same, then you are allowing by default on your firewall. If you want to deny them, if you want to deny 2 same zone traffic, you got to create a policy on top of it to deny them. Yeah, this is a default policy. It's automatically available on the firewall. Yeah, it's not something that I have created here. Okay. This one is interzone. So if the traffic is between 2 different zones, it's by default denied. And if you want to allow them, obviously you got to create a policy on top of it. Yeah. All right. So this is your NAT policy. Yeah. So here there is no default policy as such. You just have to create a NAT policy. This is the original packet and this is the translated packet. We'll go over in details of what different types of NAT we have. We'll demonstrate all of them no later on. And other types of policies over here. So we will be mostly touching base upon NAT security policy, PBF, If required, we'll go over decryption and application override. Yeah, so we'll talk about all of them. This is the policy optimizer here. If you want to talk about this is nothing but it's an automation tool, a short automation tool inside the firewall, where it will filter your unused rules for 30 days, unused rules in 90 days, and which are not at all used at all. Right. So with this, you will be able to clean up rules which are not being used but being created on the firewall. Right. So just unwanted rules can be cleaned up with the help of this small optimizer that you have from the firewall. Okay. The next one is objects. So as you know, in traditional firewalls, you create objects, for example, LAN 1, LAN 2, LAN 3, and give your respective values for that, IP addresses or networks. Similarly, you could create objects here as well, addresses, address groups. You could create applications, application groups, services, service groups. Services, service group are nothing but port numbers and protocols. Application groups are nothing but the end application. So if you see, as I mentioned earlier, both your URLs and applications are categorized based on the categories mentioned here. If you see that, uh, if I say media, if I choose the main category to be media and I say gaming as subcategory, I have these many applications that comes under media and gaming category. Okay, I can just create a group based on the category, and I'll be able to allow the traffic for a certain number of users or certain number of networks for them to access this specific category based applications. Okay. Similarly, you can also do that with URL category here. If I go add a URL category and I can add a type to be category match instead of URL list. URL list means that you are actually adding number of URLs for your users to access. You can just add this URL category in your policy and say that this URLs can be allowed for the users. If you are supposed to restrict them based on category, you could just add the category here and say what type of category you should allow or deny. Okay. So both with your application and your URL filtering, you will be able to achieve by controlling the traffic based on the category. Right. Similarly, as I mentioned, the security profiles. You have URL filtering profile, you have vulnerability protection, anti-spyware, antivirus profile, wildfire analysis. So all of them are here under objects. So these are all obsolete. You don't have inbuilt software-based SD-WAN anymore with Palo Alto. They have been moved to uh, Prisma SD-WAN Eon devices. It's a hardware device that you have from Palo Alto, which is a new gen device. You are not going to use these SD-WAN based software-based features anymore. So we are not going to go over this one right now. Okay, apart from that, that's about your objects tab. Network tab is all about your routing, your interface configuration, DHCP, DNS, IPsec, and all the other information that you could do with respect to any router or any firewall. Yeah, so it's about configuring DHCP, configuring your routing information, BGP, OSPF, and whatever zones interfaces, and you can also configure IPsec based parameters here. And device tab, it's going to be your management interface config, taking backups, shutting down the device, restarting the device, configuring host name, activating certificates, licenses, and all those stuff. So if you just come down from this list, you have your software tab where you'll be able to upgrade your firewalls from here. And dynamic updates, you'll be able to activate your licenses from here under licenses, and you'll be able to activate um, antivirus and threat prevention licenses or updates from here. You'll be able to update your threat information from the cloud from this tab. Okay. Apart from that, you can create certificates for your authentication purposes. Also creating administrators. So for now, I hope we have one admin, one user, which is admin user, and that's the user that I'm logged in from. I can create additional users here. Let's say I say user one, um, and I'll say the password to be something. Okay, so till this point, it's okay. Administrator type, you can either say dynamic or role based. So if you say dynamic, you already have pre-built 4 administrator types here. So if you see super user, he has everything. He has access to everything. Super user read only, he can access everything, meaning he can view everything, but he cannot edit anything. It's a read only mode, right? Device administrator, it's similar to super user. He has access to everything, but he will not be able to have access to the administrator tab that I'm currently on. Yeah. Device administrator read only, it's a read only version of device administrator. So you have pre-built 4 dynamic administrator type that you can use. As you see, the user that I've logged in right now, he's a super user. Uh, he has a super user role, which means he can do anything on the firewall. All right. So apart from this, I can also do a role-based administrator type where I have to define a profile. So the profile should be created over here under admin roles, where I can specifically say, of course, I have pre-built roles over here, but let me try to create one to show you how it looks like. So if you see, this one will have all the tabs that are available in my firewall, tabs and subtabs. Let's say, for example, the legends are here where the tick mark says enable, this is read only, and this is disable, right? So when I just keep clicking here, it changes the roles. So if I say under monitor tab, I shouldn't be accessing anything, which means the user will not be able to see the monitor tab at all. So let me say that he should see monitor tab, ACC, and dashboard. Let's say he shouldn't be seeing objects tab, network tab, device tab. So apart from the first 3 tabs in the list, let's say he shouldn't be able to see anything. Okay, so dashboard, ACC, monitor is something that he can work with, and you can also filter them based on command line, REST API, and XML API. Let's say this one is for user 1 role, and let me click OK. And I can apply this to the administrator that I'm going to create right now. I'll say user 1. I'll create a password for him. And I'll go role based. And I think you can also do this by saying dynamic user group user role. But I think this is straightforward. He has access to everything. This guy has access to everything, but it's only read only. This guy has access to everything, but he only will be able to view he cannot view administrator tab. Apart from that, he can access everything. And this is again the read only version of the device administrator. So let me go role based and say the role that I've created, user 1 role, where you should be able to see only the specific tabs that I have allowed him to see. Password policy again, this is nothing but the password policy that you see here. You can create a policy and say that the password of the user should be 15 characters, or it should be of this length, it expires in this so and so date within 30 days of creation, or so on and so forth. Let me not do that. It's a straightforward thing. If required, you could do it. And let me click OK. And every change that you do on the firewall has to be saved or committed. So it's not like Cisco. You have to commit your changes as and when you do it. I think Fortinet also does not have a option to commit. You only just save that specific tab, and that's about it. So here you could validate the changes that you made, and you can also commit it. You can also commit the change that you have made, not all the changes. That's also something that you have. You could preview your changes. You could check the change summary, and also can validate the commit to see if the changes that you made is valid. And if you commit, will the commit succeed? Now you can also validate that. You can give a comment here. Let me commit the change. Once this is committed, let me log out and log in using the username that I see that I've created, the user 1. So the commit usually takes about a minute for us to get this completed. Once the commit is complete, we can log out of the session and log in using the username that I have created. Actually, the plan was to show you a different lab, but due to time constraints, I had to get this done short. I was about to show you a lab where a user um, can access internet by creating an ad policy, security policy, and everything. But yeah, we will take that later. We're going to look at much more in detail about NAT and security policies. But for now, let's just get it done with this lab. So once the commit is done, we should see a success message here, which should be something like this. Commit successfully done. And let's close this and we'll log out here. This is the place to log out of the session. And let's log in again. I'm logging in using the new user. And I think he should be able to see only 3 tabs: dashboard, ACC, and monitor tab. Okay, did I not? Okay, did I not remove policies? Maybe I did not. If you see, he's only able to, we are only able to see limited tabs here, whatever I've allowed inside the role-based administrator role. I'm not able to see anything more than that. So this confirms that our administrator user with that specific role that I've created is working. So I'll not be able to change the role here because I don't have that tab at all available. So if required, I'll have to log out and log in using the admin username. I have to make the changes. So I can log out and log in using the other username. But yeah, I think if I log in, I should be able to make the changes. We know that. All right, so that sums up the lab, guys. So I actually thought of showing you a little bit more, but we are almost done with the session. I hope the information was delivered on what we're supposed to do today. Uh, any questions from you guys before we transfer the call to uh, the backend team for them to have some informations provided to you?
Will be able to download this lab to install it in our machine, or we
Yeah,
have to
yeah, definitely.
connect?
Exactly.
Okay.
Yes, yes, yes. You will be provided with the lab from the team. Um, you will be getting the lab access, I think, on the day from the day one of you joining the session. Yeah, you will be having this lab. Yes, definitely.
Okay, thanks.
Yeah. Any other questions before I end up the session? And for those who have asked the course curriculum, I'm just giving it to you in the chat. You can just go over this one. This should be the actual content that we will be going over in the complete session. You can just take a look at this one, the link that I have posted in the chat. Yep. That is it from my side, guys. I hope it was informative. Uh, Sajid, if you are there, you can take it over. I'm done from my side.
Yeah, I will take it from here. Thank you.
Thank you. Thanks. Thanks, guys.
Thank,
Thanks a lot for the time.
thank you.
Thank you.
Thank you. Thank you.
Hello everyone. Myself Sajid. I'm a student relationship manager and the counselor. So I'm here to give you all the details regarding this course
and what all will be the modules, and what all will be the topics, what all things will be going to cover. Okay. And can anyone please confirm, like, can you guys see my screen? So which is with the PPT presentation.
Yes, we can.
Okay, thank you. So let me start with my first slide. So as you can see here, as you guys can see here, so I have mentioned details for firewall mastery, find one combo course, okay, which covers Palo Alto. In Palo Alto, we are covering PCNSA, PCNSE, and Panorama 2. And the next will be the Fortigate. In Fortigate, we are covering NSE 4 plus NSE 7. And then next will be the Cisco ASA FTD. Okay. And Cisco ASA FTD, FMC, and Firepower. So this will be covered in this section itself in the Cisco ASA Firewall course. And then next will be the Checkpoint Firewall. And then next will be the FILTM load balancer. So overall combination of 4 firewalls and one load balancer. So we have this firewall master 5-in-1 combo course. Okay, so let's talk about the schedule. So this will be going to be a weekend batch, Saturday and Sunday. So from 9 a.m. to 11 a.m. IST. 2 days on weekend, Saturday and Sunday. Each session will be of 2 hours, and the overall course duration will comes up for 5 months. Okay, and yeah, so let me move towards the next slide. So as you guys can see here, so I have mentioned details for the course enrollment and access details, like what all access you'll be getting once you are going to enroll for this course. Okay, so let me tell you, like, once you are going to enroll for this course, like, you'll be getting the lifetime recording access. Means like what all classes you'll be attending through the Zoom meeting. So that will be recorded in the cloud, and that will be uploaded to the LMS web portal. So from there you can access your class recordings. Once the class is completed in meantime of 1 to 2 hours, the recordings are visible in your LMS. So whenever you want, you can go through the recordings. If in case if you missed out the session for today, so you can go through the recording and you can catch up in next class. Okay. So in the same session, if you have any doubt, you can clear it in the next class. So like this, you can easily like be on the track with the course, and you'll be having the recordings access for lifetime. Whenever you want, you can access it. And secondly, we'll be providing you the remote lab access, which will be for 24/7 unlimited, which are hosted on our servers and cloud servers. Like for dedicatedly 3 months of lab access you'll be getting. For Palo to 3 months, for Fortigate 3 months, for Checkpoint 3 months, for ASA Firewall 3 months, and for FILTM load balancer 3 months. So overall, for each and every module, you will be getting the 3 months of separate lab access that can be accessible 24/7 unlimited. Whenever you want, you can access it. Okay. And we'll be providing you the dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals, all the materials we will be providing you that you can download and you can keep it with you as well. And the G Drive access remains with you for lifetime. If in case if you missed out any material, you can re-download it once again. Okay. And let's say if you have the good configuration of your system, then we'll be helping you to set up a home lab, so that once you are done with your remote lab access, further you can practice on your personal laptop. And yeah, that will also remain with you for lifetime accessible. You just need to have the good configuration, and you need to download the files from our portal. So we'll be providing you the files and everything for the home lab setup. You just need to download and let us know. So one of our team member will connect, and he or she will be doing the setup on your system. Okay. And we'll be providing you the 24/7 backend